Good morning, everyone. Today we are going to start the new topic that is called as type checking. So before starting the topic, let's revise some concept. We have studied grammar, right? Now suppose there is a production rule E plus E. Finally, if you will solve this production rule using syntax tree or the semantic tree, finally the E plus E will be replaced by ID, which means at the end of the tree, you will write or you will replace this E with ID, that is identifier, right? But the meaning of this particular rule is not defined. The meaning is not defined in this grammar. Now suppose this ID plus ID is actually replaced by integer plus integer, which means the value which is replaced by the ID is a type of integer, which means you are adding two integer values. Then there is no problem. But if one value is character and another value is integer, then what is the rule that is going to be applicable? Like if you are adding one value as integer, another value as character, then what should be the result? You have no idea, right? Or if there are two values which are character and you are applying addition with that, then what will be the result? This is called as meaning of the expression. So if the operator is applied on the operand, then you have to define what should be the meaning of the expression. If it is integer plus integer, no problem. But if you are adding or you are defining the multiplication operator with character and integer, or character and character, or character with float, or integer with float, then what should be the meaning of that expression? Which means what kind of result this expression is going to generate, right? So these things are related with the topic type checking. For example, if we talk about Java, and suppose one ID value is ABC and another ID is replaced by XYZ, and if we apply ID plus ID, then obviously the result will be concatenation ABC XYZ, which means the expression meaning is defined in the Java while designing the compiler. If the ID value is character, then it should be concatenated, and if the ID value is integer, then it should be added and result will be generated as integer, right? So these are the type checking meanings that we need to define as a developer while designing the compiler. Okay, so one more thing. But if you do this particular thing in C, what will happen? It will take the ASCII value of the character and will add the ASCII value and generate the result in the form of ASCII value. So the meaning of the operator and operand in the expression can differ language to language. It is totally depend on the developer who is designing the compiler, what kind of meaning he has fed to a particular expression while defining the SDT of that expression. SDT we have already learned in the semantic analysis phase. Although this part is also should be covered in the semantic analysis phase, but now we are covering this topic, right? So finally, who is responsible to check whether it is a string operand or integer operand or float operand? That is the responsibility of the compiler. कौन चेक करेगा कि जो आपने ऑपरेंड पास करा है ऑपरेटर के साथ, वो कैरेक्टर है, फ्लोट है, इंटीजर है, स्ट्रिंग है, किस टाइप का है, ये सारी चीजें कौन चेक करेगा? कंपाइलर चेक करेगा. तो it is very important as a developer when you are designing a compiler, you should define the meaning of the identifier as well as meaning of the operator. Fine. So in this lecture, we are going to cover following topics. First, type checking. What is type checking? This we'll learn in the detail. Next, Actually, we are starting a second unit, the fourth unit. So in fourth unit, these are the topics that we are going to cover. So I'm writing one by one. Then after type checking, when we are clear with the type checking, we'll discuss about static versus dynamic type checking. Right? The third topic that we are going to clear in this particular lecture is type expression. What is the meaning of type expression? And the fourth topic that we will cover is type equivalence. Fine. And the last topic that we'll cover under this topic is type conversion. Right? So first of all, we'll discuss about the type checking. So let's take in a short. Type checking means what is the type of the identifier? What is the meaning of the type of the identifier when it is applied in a particular expression? For example, if you are writing an expression which is applied on plus by using integer values, then what should be the final value of that particular expression and what should be the type of that particular expression, right? For example, integer is equal to integer plus integer, no problem. But if you are writing character is equal to integer, then what should be the meaning of this expression? So these type of things we will handle when we are developing the type checking in the compiler, right? Now, what is a static versus dynamic type checking? Type checking can be of two types. According to the, it depends on the programming language or the compiler development of the programming language. If it is a static type checking, then the type of the expression will be checked at the compile time. We'll see in the detail. And if it is a dynamic type checking, then the type of the expression will be checked at the runtime. Fine. So there are various languages which uses static checking, and there are certain languages, modern languages, that uses dynamic type checking. Now the third topic we will cover is the type expression. What is the meaning of type expression? There are certain languages which allow abstract data type. For example, you can design a structure in the C language, right? You can design a structure in the C language. You can design union in the C language. You can design array in the C language, or you can design class in the object-oriented language, etc. These are abstract data type. What is the meaning of abstract data type? These are the collection of the primary data type. Fine. So if I apply structure to a particular expression, then what should be the type of that particular expression? If I apply array to a particular expression, then what should be the type of that particular expression? So type expression means when you are using abstract data type, user-defined data type in a particular expression, then what should be the final type of that expression? This topic is called as type expression. Now, what is the meaning of type equivalence? Type equivalence says that if you have defined a particular type and there is one more variable of a particular type, so whether these two identifiers are equal or not. Now let's take one example. Suppose in C language, we have a command type def, right? I have defined type def xyz and the variable is a. There is no problem. What is the integer? Which means I'm defining an alias for integer data type as xyz, right? Now, after that, I have defined two variables. One is xyz a and one is integer b. Now, how the compiler will know whether a and b are equal, type is equal or not? Who will define this? The programmer will define this while developing the compiler, that which kind of expressions are equivalent and which kind of expressions are not equivalent. Actually, if you see a program as an end user, then you can say that A and B are not equal. But actually, in the backend, XYZ belongs to the integer. It is actually a secondary name we have defined for the integer, and B is directly defined as integer. So in the compiler development, the programmer should define if you are using alias for a particular primary data type or a abstract data type, and you are using direct variable for that data type, then both data types are equal actually. Both identifiers are equal actually. Now what is type conversion? If you want to convert one data type into another data type, then it is called as type conversion. We have already seen implicit type conversion or explicit type conversion. Now, what is the meaning of type conversion? Suppose I'm writing integer a is equal to a is integer, and I'm defining, and there is one more variable float, say b, or integer a and float b, right? Float b. Now I'm defining b is equal to a. Now if we see b is a float, a is a integer. What is the meaning of that? It is a type unequivalence, which means you are trying to store integer into the float. Now here comes the role of developer, compiler developer. He need to define if there are two unequal type identifier, then how to handle the situation. Now, if your language type checking is defined as implicit type checking, then automatically integer will be converted into float and it is stored in the 4 byte. But if the implicit data type checking is not defined in your compiler or in your language, then you are storing 2 bytes into 4 bytes, then which part of 2 byte is going where into the 4 byte? And if you are storing 4 byte into 2 byte, suppose you are writing a is equal to b, which means you are storing 4 byte into 2 byte, then what part of data is going to be loss, right? So these things is going to be handled in the topic type conversion. Suppose your language supports explicit type, right? So what we write, suppose if we talk about the C language, it supports explicit type conversion. So what we are doing, we are converting a in the static time as a float, and this is going to be stored into b, so there is no problem. Now it is type compatible, right? And in this case, if I write integer for the b, then it is automatically converted into 2 byte. If it can be, then it will be stored into a, right? So generally this is not supported by C language. Okay, so this is all about the topic that we are going to cover in this particular lecture. So let's start with the type checking. What is type checking actually? So what is type checking? We'll take every topic one by one. So basically, type checking is what? Type checking is the semantic aspect of the compiler. First and important thing, it is a semantic aspect of the compiler. What is the meaning of that? The type checking cannot be done or cannot be checked at the time of syntax analysis. When we talk about the parser is only responsible to check syntactical rule of the language. It is not supposed to check semantic rules or the type checking of the language. So this particular thing is actually a responsibility of semantic analyzer, right? So this is the first point. Now, what is the second point? Okay, now it defines meaning of the operator and operands. It is used to define meaning of the operator and operands. That we have already discussed. Plus, if it is applied with the character value, what will happen? Plus, if it is applied with the character and integer value, what will happen? Plus, if it is defined with the character values, what will happen? So basically, semantic in the type checking, semantic analyzer, while designing with the semantic analyzer, we have to define what is the meaning of operator and what is the meaning of operand, right? Now, third, it is used to assign values. It is used to assign types to value. What is the meaning of that? Value will be assigned to the expression, right? What is the meaning? If id is equal to id plus id is written, and this id is integer and this id is float, then what should be the value of this expression, right? If this is integer, this is float, what should be the value of the expression? That is the resultant. If this is integer, this is also integer, then what should be the value of the expression? If this is float and this is also float, then what should be the value of the expression? We are talking about the whole value after calculation, right? So this should be also handled by the semantic analyzer while handling the type checking. It should report type check error, in case of violation. If there is any violation found in the type checking, then your semantic analyzer should be able to report that error, right? Okay. Now, generally in the modern languages, there are two types of language. One is called as a strong type language, and another is called as weak or average type language, right? So what is the difference between these languages? If the language is a strong type language, then all type of type checking will be handled. If there is any problem in the type check of the expression, it will be handled at the compile time and your compiler will give the error. But if it's a weak typed language, then there will be so much flexibility. Maybe you will find some different type of output so that you'll come to know you have done something wrong in the program logic, but it won't give you direct error in the program at the time of compilation, or it will give you warning and that can be ignored. Your program will be compiled, warning will be there. If you're ignoring the warning, then you can't check at the compile time whether why your program is giving wrong output. This can be only checked at by checking the flow of the program and logic of the program, and every expression, what is wrong you have typed or what is wrong you have written in the language while defining the program. Okay, now last thing it will check if the correct type is found incorrect. Okay, what is the meaning of that? Suppose you are trying to store integer into the float, then what will happen? Or if you are trying, basically this can be done. See this, if you are trying to store float into the integer, then what will happen in this case? So basically in this case, your language should handle type conversion, either implicit or explicit. If you have not written explicit, then it should handle implicit. Otherwise, your language will take Otherwise, your compiler will take decision. What part of the value should be stored into the resultant? This is called as type coercion. Right? Which means the type of the value will be decided by the compiler and will be stored into the resultant identifier. So this implicit type conversion is called as type coercion. So this is all about the type checking. So in case of type checking, there are 5 responsibility of the semantic analyzer, or the 5 responsibility of the compiler. First, the type checking will be done by the semantic analyzer only. So it is a semantic aspect. Second, the compiler should have meaning of operator and operand, right? Third, assign types of the value. The whole, what kind of value the whole expression will have after solving the right hand side, right? And fourth, type report if there is any error in the type checking. So there are 2 types of languages in this case. Strong type, if the language is a strong type, then compiler definitely report you error and your program will not be compiled. But if it is a weak type language, then your compiler won't report any error at the compile time, but it can show you warning or your output will be wrongly generated. And the programmer will then identify manually where is the error, right? Now, fifth responsibility of the type checking part is the correct type, but if it is found incorrect, right? Like you're storing float into the integer, float is of 4 byte, integer is of 2 byte. Then your compiler will do implicit conversion. This is called as type coercion. The decision will be taken by the compiler that what part of the 4 byte will be stored into the 2 byte, right? So some value will be lost and some value will be stored into the integer identifier. So I'm stopping my lecture here only. In the next lecture, we will discuss about the rest of the topic, like static versus dynamic checking and other rest of the topics, right?